Class 8. Um, Welcome to the second class of online teaching. Same instructions. Basically, we're studying chapter 8, the rock cycle, and same instructions that were given last time. Now, before I begin, let me tell you today's objective. So, the objectives of today are basically that you need to understand and relate the size of the grains to where the crystal was formed, how the crystals are big, how they are small, what affects the size of crystal, and relate the speed of cooling to the crystal, and explain in terms of the particle model. Then you will use some data to assign the igneous rocks to one of the main groups and find the dense iron rich or less dense silica rich. And you'll show how relative density relates to the composition of igneous rocks and recognize how the rock cycle provides a continuous supply and transformation of the earth through the rock cycle. And go ahead and open your copies to write the index of today, 20th of March, online lesson 2, rock cycle. So open your books to page number 180. This is one of the activities where they have basically copper sulfate crystals, and there are two types of copper sulfate crystals. Now, if you see, one are very small crystals while the other one are very large crystals. Why are they small or large? Let's have a look. According to your book, according to the particle model, matter is composed of particles, and they're in constant and random motion. In a liquid, the particles are basically constantly and randomly moving around. On cooling, the particles come closer together, and the longer it takes to cool, the more particles will come together to form bigger crystals. So in short, if you are cooling the crystal slowly, it will form bigger crystals because they get time to arrange more properly. And if you cool them very, very rapidly, they form smaller crystals because they don't get time to arrange themselves. So this is according to particle model of matter. Because this takes longer to cool, the particles come close to form bigger crystals. Moving ahead, the igneous rocks basically are classified based on their texture. Those with large crystals formed inside the earth, and those with small or no crystals formed on the surface of the earth. And another way to classify the igneous rocks is by mineral composition. Some are rich in silica while others are rich in iron. So look at this table on page number 181 of your book. If basalt, gabbro and granite, basalt and gabbro are rich in iron, while granite and obsidian, they are rich in silica. Now what we have to do basically is an experiment as well. I wish we were in the school, but I can guide you right now. So basically they are telling us to compare the densities of silica rich or iron rich igneous rocks. So they're saying that take gabbro and granite. Gabbro is iron rich and granite is silica rich. Okay? We are going to take two kinds of rocks, and we are going to find the mass in kilograms, which regularly we can find, okay? I am chemical balance. And after that mass has been found, we need to find the density. So density is equals to mass over volume. Now volume is basically going to be found by a displacement method. This is the displacement method. So you'll have water in one beaker, and once you place the rock inside the beaker, the volume will rise. The amount of volume that will rise is going to be the volume of that particular rock, basically. So by finding the volume, you've already found the mass. So you'll divide mass over volume and you'll get the density. And let me tell you, the density of iron is much more compared to the density of silica. So probably gabbro will have higher density. Now moving ahead, the most important topic, you could say the heart of the chapter, is basically the rock cycle. The rock cycle is an ongoing process. Please kindly go ahead open your books to page number 182. Read this paragraph very carefully. You can pause the video for the meantime. And after you're done reading, you can go on to the next.